Reducing balance loans. A home loan of $170,000 is taken out at a rate of 12% per annum, reducible monthly, with a monthly repayment of $2,000. The first thing we have to notice is that this interest rate is per annum, but it is reducible monthly with a monthly repayment of $2,000. So we have to convert that to a monthly interest rate. Whatever the interest rate is, we divide by 12 because we have 12 months in a year. So here we have a monthly interest rate of 1%. In calculating the interest every month, we are going to use the simple interest formula. I equals P times R times N. The principal will come from the outstanding amount at the beginning of each month, and the interest rate will be the monthly interest rate as a decimal, so it's 1 divided by 100 is 0.01. The number of time periods will be 1 because we're just calculating 1 month's interest every time. Let's look at the first month. We have an outstanding amount of $170,000. We times that by the 1% of interest for 1 month. And that gives us interest for month 1 of $1,700. The next column shows us that we have to add whatever we owed at the beginning of the month plus the extra interest charged on that. So we now owe a total of $171,700. But we have also paid $2,000, so we can subtract that $2,000 from the amount we owe. So the end of the first month, we then only owe $169,700. If we go to the second month, whatever we have at the end of month 1, we now stick in the beginning of month 2. So I bring over my $169,700. And I'm now going to repeat the whole process. Calculating the interest for month 2. The amount outstanding in month 2 is the $169,700 times interest rate of 1% for 1 month is an interest amount of $1,697 for month 1. Adding the amount outstanding in the beginning plus the interest for that month means at the end of that month I have $171,397. Once again, I have paid $2,000, so I can subtract that. So that leaves me with $169,397. Once again, whatever I have left at the end of month 2, I'm now going to take to beginning of month 3. So I start month 3 with an outstanding amount of $169,397. I apply the simple interest formula again. Whatever is outstanding at the beginning of that month times the 1% for the 1 month gives interest for month 3 of $1,693.97. Adding the interest to the principal at the beginning of the month gives me $171.90, and 97 cents. Once again, I have paid $2,000 in that month. So the total outstanding at end of month 3 is 169,090 and 97 cents. Once again, whatever is outstanding at the end of month 3 will be what I take to beginning of month 4. $169,090.97. I repeat the simple interest formula, and that gives me interest for the 4th month of $1,690.91. Once again, I add the principal plus the interest charged on that outstanding amount, and that gives me $170,781.88. Every month I pay my $2,000, so the total amount outstanding at the end of the 4th month is $168,781.88. I can now see that although I have paid a total of $8,000 over the 4 months, which might lead me to expect that I now only have $162,000 outstanding, I actually still have a total of $168,781 outstanding, which means the difference between these two amounts went to cover the interest charged on the amount for the 4 months. So if I subtract those two, I can see the interest charged on the loan amount for the 4 months is $6,781.88. You have to do question 1 in your exercise books. A home loan of $420,000 is taken out at a rate of 6% per annum, reducible monthly, with a monthly repayment of $4,500. Remember to convert that interest rate to a monthly interest rate. Copy this table into your exercise book, and please remember to show all working out very clearly. Applying the principles we have just used, banks have tables that show monthly repayments per $1,000 at specific interest rates for certain periods of times, and that makes the amount of work we have to do a lot less. Let's look at an example where you have a home loan or a personal loan for $9,000 at 8% for 15 years. You use the table to find the factor for 8% and 15 years. And then this table gives you the repayments per $1,000. So you take the $9,000, which is the total amount of the loan, divide it by 1,000 first, and then times it by the factor given in the table. And that will give a monthly repayment of $86.01 per month for every month for 15 years, which is a very easy calculation. Just always check exactly what information the table gives you. Here you have to pay attention that it's a monthly repayment and that it's per $1,000 to take into account when you do your own calculations. Here is a copy of that same table again for you to answer question 2 in your exercise books. Use the monthly repayment per $1,000 table below to find the monthly repayment on a loan of $140,000 over 20 years at 7% per annum. Other tables banks use give monthly repayments for loans of different amounts where interest rates usually vary as the term varies. Typically, a loan with a longer period of time will have a higher interest rate, and this would have already been incorporated in the figures shown here. Very easy to use these tables. If you want to look for the monthly repayment of a loan of $7,000 for 6 years, you can straight away see the monthly repayment will be $134.86 for every month for 6 years. And you just read the answer straight from the table. You now have to use this table to answer question 3 in your exercise book, where you have to use the table to find the monthly repayment of a loan of $9,000 for 4.5 years. And that concludes the work for this part of the topic.